I'm from Portugal. My company called Allbesmart. Our main goal is Wi-Fi networks, real crowded Wi-Fi networks. So we have developed this experiment to try to test what is the scenario, what will happen in the real crowd scenario of people. So we have to try to improve the performance of the network Wi-Fi installed by us. So for that, in the beginning, we have some kind of troubles because we want to know what really going to happen, but we don't have the sources or the funding through trying to develop that. So what we do, we call it to this, we write to a proposal to the FEC1 that will goes okay because I'm here, no. So with this we can apply for fundings and simulate what our next project, because our next project will happen in a small city where we are in Castelo Branco, a public swimming pool. We have to provide during the summer about 1,000 people free internet for about 1,000 people. That will be quite challenging. And at the beginning, we don't have the fundings enough to make the tests. Okay, so we have to implement by almost blinding implementation, and then try the best manually, try to configure the optimal performance of the network manually. So what we have to do? Okay, we have this project, we have the founding code. So let's try and benchmarking the network to see what we came across. So what we have to do, this is a small example, only with with a limited number of access points to the people to understand better what we are talking about. So what you have here, this is a small explanation. This is the channels, Wi-Fi channels that we have available to transmit. So what we have do, we have the Wi-Fi spectrum sensors. These Wi-Fi spectrum sensors will provide us all the information that we need, that will happen in all the space where we are, all the SSIDs, the power that everyone transmit, all that information. So that information will be stored in a database. That database will be analyzed by a radio environment map builder. We'll do something to explain and to see better. We'll provide this image like this. This is just to we see what happens. So then, once we have this image, we can do to the resource radio map and to directly interact with the access points. So once we have the radio environment map, will give us the possibility to say, okay, there are some interference and some access points. Do we need to check them and to change the channel to avoid that interference? Okay, so we have a small example. We have several links, 5 links to be exact, and we come across with the interference link. So what is our first scenario? The first thing that we have to do is just a simple scenario. We have put all links in the same channel. As we can see, the performance is really poor. We have the aggregate throughput, that is the sum of all the links, only 22.34 megabits per second, which is really low performance and really poor. So what we do next is we manually make the optimal channel distribution of our small network. Once we have that, we have a really increase in throughput. We pass from 22 to 71 megabits per second. What we come across here is for our surprise, or for our experience that we have crossed, and make a big notice that these make us go back to some project that we already developed and make small changes because of this project. One was that because we always put our access points to the maximum power. That is not a really great thing to do, as we can see here, because once we have augmenting power, we'll decrease our performance network. That is a bad thing, because once we have provided a bigger power, we also implement a bigger interference. So that is a problem that we just realized through the simulations. Then what we come across, we try to apply all the automated system automatically. So what we have provided several links, and then the interference channel appear. Okay, in the same channel, this case the same channel at the link 2. As you can see in the link 2, okay, the throughput that earlier was big enough as 11.76, now is 6.8, really low performance. So because of this channel that is interference in the same channel, the two are in the channel 11. After our radio resource map strategy, we applied our algorithms and reconfigured the network automatically. Once the network will reconfigure automatically, they avoid the cold channel interference and adjacent channel interference. They avoid all that questions and redistribute again 6, 1, 6, 11 and 1. And we have got back our performance that we like and that we have put in our manual configuration. So now it's perfect. Another thing that we came across is the channel relocation triggered, because sometimes we have the channel 1 occupied. Okay, let's use the 2. No, this is bad because we have adjacent channel interference that is the same as the cold channel interference, as you can see here. Because if you configure the channel that is right next to them, next or before them, it will be a big mistake and we have a low performance network that we want to avoid. So the business impact in our company will be big, because with the fundings provided by the FEC1, it allows us to develop, test and develop the software that we need and hardware that we need to implement this in the real crowd scenario, in this case in the swimming pool at Castelo Branco, that will work real good. That's a real fact. Also provide us a real good knowledge to interact in the projects that we have developed. We go back to 2 or 3 places that we have developed projects or to Wi-Fi and put the routers to the minimum of power because of our findings here in the benchmarking. So and reinforcing our part for the FEC1 configuration, aside of this project, we also have, as described here in the poster, we have the portable testbed. What is the portable testbed? Is a testbed that make also that have the same tools that we have in the remote access lab. So what this testbed allows us is to simulate in the real scenario environment all the doubts that we have, all the scenarios, things that may become, and then allow us to test all in the real scenario.